Welcome to Data Brew by Databricks with Denny and Brooke. The series allows us to explore various topics in the data and AI community. And whether we're talking about data engineering or data science, we interview subject matter experts to dive deeper into these topics while we're enjoying our morning brew. My name is Denny Lee. I'm a principal developer advocate here at Databricks and one half of Data Brew.
And hello, I'm Brooke Wenig, Director of the Machine Learning Practice at Databricks and the other half of Databrew. And today we are thrilled to have the co-authors of SWE-agent on Databrew today. We have Kilian Lieret, Research Software Engineer at Princeton University, and Carlos Jimenez as Computer Science PhD candidate at Princeton. Welcome both.
Hi.
Before we dive into SWE-agent, perhaps let's take a step back. Carlos, I know you're the first author on SWE-bench. Perhaps we could start off with what is SWE-bench and what was the motivation behind creating SWE-bench?
Yeah, so SWE-bench is a benchmark to evaluate language models. And in particular, we're trying to evaluate language models on their ability to write code in a more production-like setting. Prior to SWE-bench, a lot of the coding evaluations around language models focused on settings that were more like interview question type problems, or maybe like coding competition type problems, where the problem was maybe self-contained, and the language model was supposed to write maybe one function that did something like finding some optimal solution to a particular thing in a algorithmically efficient kind of way. And but in the real world, a lot of people's actual time spent software engineering is less on this algorithmic, isolated solution problem solving and more on maintaining big software systems, making sure your systems are bug free. They can be large on large complicated code bases. And so with SWE-bench, the idea is that we want to find a way to have some of the same types of problems where you can provide a language model with a specific isolated problem, but within the context of a large code base. And so the way we did that is essentially is scrape issues from GitHub. And these are types of problems that a lot of real world software engineers spend their actual time and jobs fixing, and essentially packaging it to present to a language model so that we can evaluate their ability to solve those problems in a production like type setting.
And how do you avoid the issue of data leakage? If you're scraping all these GitHub issues, sometimes people will include useful snippets in the comments. How do you avoid data leakage when you're trying to evaluate these models?
Yeah, so that's a good question. I would say, in some sense, it's very hard to avoid contamination or leakage in a very strong, kind of strict way. Everything on the internet is up for grabs for these companies or for people training language models. And so it's almost, I would say, it's near impossible to get really clean, uncontaminated data sources. Now, with something like SWE-bench, however, we are using some logical structure in how the issues are organized within GitHub, such that oftentimes the solutions don't necessarily show up right next to the problems. And unless you're scraping in such a way to really pair these two things together, it might not be, it's not necessarily that easy, I think, to inadvertently cheat on SWE-bench problems. That's not to say that contamination doesn't exist. It probably does to some degree, but I don't think that the way that these models are trained, I think unless you're explicitly training models to solve SWE-bench type problems, it's most of the performance is not directly from contamination.
We also have this breakdown, right? Like over time, right? There's the number of resolved
Mm,
instances over time. There's various effects that can be found there. I think for some of our benchmarks, I think for multimodal, we actually found that the newer the issues were, the more we would resolve, like the opposite of what you would expect from contamination. So certainly there's like a lot of other effect. It might just be that issues get in big repositories get easier over time. I think so far we've never seen this trend that you would expect from a clear contamination thing where, like suddenly for some, especially like older years, you suddenly see like it dramatically rising the resolve rates.
Then one thing I'm curious about, because you noted your description about SWE-bench is to be able to look at in totality, right? To look at the problem, not just an isolated function. But there are plenty of GitHub repos, for example, that within the repo, it represents multiple modalities or multiple problems, right? Or In some cases, it's not just the individual repo, but within the org, or for that matter, some other tightly coupled with other repos. I'm just curious, is there something about SWE-bench you specifically resolve for that, or in fact, the reality of this particular situation because of all of these potential connection points, both either improve or decrease the likelihood of this type of contamination that you're referring to?
Yeah. I think maybe it's a little bit hard to think about it at that level, but generally speaking, like the scope of a single problem in SWE-bench is just going to be like a GitHub issue. And so it's usually going to be some specific bug. And that bug might be isolated in some way, or maybe not. Maybe it's something that like to actually resolve it, you have to change multiple different functions across different files or change the structure of your code base in some way. So the complexity can really range from very simple isolated problems, which still happens within the context of a big code base even, to much more structural, bigger refactors necessary to fix those types of problems. And I think it's a little bit problem specific, but generally speaking, what I would say in terms of contamination, I just think that the way that language companies are maybe scraping data from GitHub in order to train their language models are not really optimized to solve SWE-bench types of problems. And so while it definitely might have seen like the literal text in most SWE-bench issues, for instance, it's probably not, unless you're training to solve SWE-bench problems, it's probably not like a humongous advantage.
Because the pull requests and issues aren't necessarily paired, right? So it might also see a lot of pull requests, but it doesn't necessarily see. Often, there's a pull request just linked to the issue, but unless it's specifically follows the links, it doesn't see like this problem solution pairing, right?
Yeah, exactly.
Mm.
You're implying that people in GitHub aren't super organized and ensure everything's clarified? No, obviously I say that in jest because, of course, my code's perfect, but not even remotely close to true. But what I'm curious about is then related specific to SWE-bench before we make that switch to SWE-agent. Is there like what is the makeup of the data sets, i.e., the GitHub repos that typically comprise of it? Is there a particular language set that you're targeting? Is there, or is it just more the entirety of all of GitHub? I'm curious as to how the data set, quote unquote, is built up for SWE-bench.
Mm. So for SWE-bench, it's mostly Python repositories. The reason for that, I would say, is mostly because of our one, it's a very popular language, and also our familiarity with Python is like much higher for them than for most other like languages, at least recently. And so when we were building SWE-bench, one of the big parts to make SWE-bench work is essentially making sure that you can build like the execution environments for these repositories. And because we're better at Python than other languages, it's easier for us to build those effectively. So yeah, in a way, SWE-bench is biased in that sense that the emphasis is on Python repositories. But I think if you have a system that's trying to solve SWE-bench problems and it's sufficiently general, that doesn't rely necessarily very extensively on Python specific features, then I think the types of problems that you'll encounter in Python are not radically different from those that you encounter in other languages.
So you should also mention that there's SWE-bench multimodal, which we mostly
Yeah.
developed to see how agents can incorporate images in issues to solve problems. But this is all JavaScript. In many ways, those are both different problems because they are more like front-end oriented because that's where the images come in. But it's also a different language, and we did definitely see when evaluating frameworks there that some frameworks are overly specific to Python, which, for example, SWE-agent is not, because it's a very I think common sense agent scaffold, which gives the agent a lot of freedom to explore. And it's really only guided by, the initial prompt that tells it has to solve an issue and gives a few tips. But other than that, the agent goes around and explores files and does whatever a human would do to solve the issue. So there's other approaches to solving SWE-bench style problems that are a little bit more RAG style. They try to accumulate all the context. They basically have a lot more tools in place to accumulate the context that you need to solve the problem. But of course, these tools will be very specific to the language. Like in Python, you can check where things are imported from. You can try to pull in these sources and so on. But you're going to end up being very specific to the language. So that's something how you can end up being overly tuned to a specific language.
And so SWE-bench is an open source project. You had mentioned it expanding from mainly a Python focus to having some JavaScript focus. What's next for SWE-bench?
Yeah. So I think right now a lot of our emphasis is maybe more on the agent side. I don't know how much I don't know how much I want to stay on record about like future evals kind of projects. So there's maybe some things happening, but I think that right now our emphasis in terms of what we're working on is a little bit more like enabling language models to tackle these problems in an agentic way.
That's a fantastic transition to SWE-agent. Perhaps, Kilian, you could give us the pitch for what is SWE-agent?
Very simply put, it's our way of solving SWE-bench style problems. And I think I already hinted at some parts about the nature there. It's a very basic loop. You start off the agent with an initial prompt. You give it the problem statement. You tell it about the tools it has at its availability, and then it proposes the first action. We execute the action for the agent. We tell it what the result of this action was, and then it just proposes the next action. And it does so until it believes that it has solved the issue, or it has run out of money that we give it, and that's it basically. So the magic here is, of course, there's this initial prompt, but then it also comes down to the tools. For example, like how can we make the agent interact with your computer or with a code base? And I think that was the big focus of the original SWE-agent paper. It was this notion of an agent computer interface, or ACI, like just how we humans, for example, we use maybe Vim or VS Code or however you want to interact with a code base, but we don't just use the Linux command line and do like file manipulation with echo and set and things like that. Because that's the context in which SWE-agent was built, was that before that, like the simplest thing you can do is give GPT-4 or whatever we use at a time access to the command line, and it's going to find all these crazy ways of editing files. It's going to spend a lot of its thinking and energy just about how to make edits. And obviously, this is not where your thinking power should go. Similar to a human, we want to not think about typing. That's why we like to touch type. We just want to think on the higher level questions. So that was the emphasis, and it's still one of the emphasis of SWE-agent. With the new version that's up since maybe 2 months or so now, it's even easier to exchange the tools. So we've organized tools in tool bundles. It's very easy to give it different tools. And we have various spin-offs of SWE-agent, for example, for cybersecurity, where we equipped it now with cybersecurity specific tools and can just run with that. I think that's the big strength of it. Like, it's not really overly optimized to one specific task.
That's really interesting. Is there an implication that the agent itself is actually leveraging the IntelliSense of a tool in order to get access to the properties and methods of a particular language?
I fully understand the question. You mean that it uses tools to actively explore the code base as well. And if you give it, for example, with the cybersecurity things we did, we gave it GDB, the debugger for C++, and was able to use
Okay.
that, even though that's like more
Got
of
it.
an interactive style thing, but it can use it to really, similar to a human, run experiments or investigate the code base in whatever way you give it access to.
Oh no, actually, ironically, that's exactly what I was referring to.
Oh,
I was just pretending the agent was almost like a human and they're literally typing it, that it pops up
yeah,
with the property and methods. But exactly to your
yeah,
point, it's actually
something like that.
using the debugger to actually figure it out, which
Yep.
is precisely the point, but probably not as slow as me typing it in VS Code, something like that. But then I'm just curious, like, why can't you implied it already, but why can't you just say, no, let me just take your frontier model, GPT-4 or Claude or whatever, and just toss it there and be done for the day? Why specifically this idea of an agent instead of actually utilizing a frontier model?
So I think that question is all about context. In order to solve a problem, you need the context. You need to know the relevant parts of the code that are responsible for the bug you're currently trying to solve. And there's different ways you can go about that. So it's not completely impossible to just use, for example, ChatGPT, and a human could do that too. If you're stuck at a certain problem, you've identified the 5 areas of your code base that are responsible or likely have a connection to the problem. You could copy paste all of these 5 different things into ChatGPT and then ask it your final question, where does the problem come from? And you'll get your result. However, you first have to get that context. And there are projects out there, some of them doing very well also on the SWE-bench leaderboard, that use static analysis of the code base. So without a language model in the loop, or maybe with a language model, they might just, a very stupid way of doing this would be to first give a cheap language model every single file and ask whether it has a connection to the problem. But anyway, you accumulate this context, and in the end, you're going to hand over the context and the problem to the language model and ask it to propose an edit. You can do that. I think you're going to invariably be much more specific to the kind of problems you're solving. That's one thing. The other thing is you can't iterate on something. So with SWE-agent, after it thinks it solved the problem, it tries to verify it. Just like a human would have like reproduce.py, it tries to create a reproduce.py, and it's going to reevaluate it to see if it really solved the issue. And if it hasn't, it's going to mess around with things a little bit more. So if you don't do this, then to make up for that, what you can do is you ask ChatGPT 100 times and try to pick the best. So there are ways to do this in a non-agentic way. It's going to be different kinds of tools, and I think we can talk about that later. Not all tools are right for it depends on really and there might be like a multitude of different tools, of different approaches coming in the future to help programmers.
And so one thing that I know that can be a challenge for agents is sometimes they can get stuck in a loop. I know things might be changing with some of the new reasoning models that are coming out, but just curious, how do you avoid issues where the agent gets stuck in a loop?
This is still a problem. It's even a problem, like, I think the naive ways to fine-tune, or like when you first try your first fine-tuning steps, that's even something that can happen even more, that a model will just try the same thing over and over again, maybe because it just has a very predefined notion of what works best in a certain situation, and it doesn't really incorporate all the history of that this doesn't actually work. So with the first version of SWE-agent that came out together with the paper, we tried to do a lot with prompts, and certainly models at that time were more prone to these kind of mistakes, and we told it very strongly that if you see that a command is not working, don't try to run the same command again. It's not going to work the second time around. Or very small, silly things like some commands don't have an output. If you're an empty folder and you do ls, there's no output. It doesn't mean your command has not run. It just meant the output is empty. So then we actually explicitly told it, like, hey, your command runs fine. There was no output. Small things like that. I think that's like the first order things you can try, and then you can go to slightly more sophisticated methods. In principle, you could sample a bunch of times from the language model, and you can pick what's best. But it's I think that's one of the problems that really limits the length also of how many steps a language model can take and still do reasonable work. I think what everyone sees is that if the agent takes many steps, the quality of its work will really degrade, similar to if a human gets stuck at a problem. I think it's a very human problem, actually. Like, most people stick to their first idea that they have at solving a problem, and they have a really hard time completely abandoning it or like coming up with a completely orthogonal second idea. Mostly they'll try variations of the first idea, and that's exactly what we see with agents.
I can definitely say I'm guilty of that. Sometimes it's like the
Me too.
code is right, and then it'll be some environment setting somewhere else. The code was fine, but it was some cache environment
Right?
variable, and just keep
Right.
rerunning, and then end up just restarting the environment, and all is good.
Exactly. I thought too, Python 3, that switch as well, right? When you're messing around with that. Oh, absolutely guilty of that.
So relatedly, what are some limitations with agents? Where do they not perform well? Just curious to get your insights on, just limitations of agents.
I think language model agents excel when problems are still somewhat isolated. If there's something obvious, like maybe not obvious, but something like maybe something easy for a human to overlook, colon in the wrong place or a sign problem or stuff like that. I feel like agents can sometimes pick up on that like quite effectively, maybe more so than humans sometimes. I think things that have to deal with like bigger systems thinking, anything that requires like looking beyond specific functions. So more bigger structural changes, refactors, all of those things are definitely quite hard. for language models still. I think that also relates a little bit to like long-term memory. So the maintainers of a repositories are invariably the fastest, most effective at fixing bugs or like making changes to that repository. And somebody who's coming at it fresh is going to have a lot more, like a lot more of a learning curve to get up to speed with understanding what the best changes to propose are going to be. And so I think the same thing with the language model is code that's extremely popular. Maybe it has a good understanding of like maybe how it would work or how it can make edits to that. But at some point, I think language models that are, yeah, maybe more specialists in particular repos or like more specialists in particular types of programming would be a lot better at solving a lot of problems. Just the way that humans, like when they specialize on something, are much better at doing that. So
Yeah, I think it's a little bit related to this, like how many steps can an agent take and still do useful or like still be top notch at its reasoning. And if you have very large problems, I think agents, like language model in general, like they want to fix everything in one go. And I think they're not very good at a human to make small, have a plan and slowly iterate on it for a very long time until they achieve it. And I think that's also something we already hinted at that once things go wrong in an agent, once it does a bad edit, the likelihood of recovering from that, I'd say is much smaller than a human. I think all of this wisdom of how do I deal with a very large problem, it's not a weakness of agents, and it's not like you can solve it in other ways. It's just something where the current state of AI is not up to par with a human, certainly.
Cool. You've got me thinking here and about how we can leverage SWE-bench and leverage definitely agents, right? But then automatically I would want to ask that question, how should an enterprise access it? And I'll probably also frame it in one of your recent comments about the fact that, okay, as time progresses, maybe we need a specialist, right, to go ahead and actually help said agent, right? Does that imply that maybe for enterprises when they have this is the golden code base, that in essence that would be the one they would train first to any newbie develop better code as they're actually working with SWE-bench and SWE-agent?
Mm. Yeah, I guess thinking from like an enterprise perspective, yeah, it depends on maybe a bit on your resources or like the size of your code bases, and I would even say like the history and size of like your repositories with respect to the data available to say specialize or build a specialist model on particular repositories. If you have those resources, I do think that you could probably essentially build like or fine tune models for the particular use cases and repos that would probably be quite strong or a lot stronger than maybe something that's just for publicly available things.
I think a very simple thing, like if you're a company, so I think you have, with SWE-bench as a benchmark also, there's certain constraints on what you're allowed to do in order to submit and things we consider cheating. For example, something that would help the agent a lot is that you could have you could make testing very simple. Like with normal submissions to SWE-bench, the agent has to find out itself how to run all the unit tests. And with something like Django, it's probably not going to work the first time. And there's ways, around that. But I think the whole environment setup and just filling with a few parameters to really tune it a little bit to your code base can get you quite far. And generally, if you have, especially, and we run it on open source repositories of maybe various degrees. I guess Django is very well tested, but generally, if you have a lot of tests and you can run them very easily, this is great for an agent because first, the agent could iterate for forever until it fixes something. And second, you can test if it breaks anything else. Or you can just run five different agents 5 times and check based on the test reports if it did well. And also what you could do, maybe for some type of problems, it's very easy to write up a test that's currently failing and you give that to the agent as well. You basically, instead of the agent having to come up with its own reproduction script, like in SWE-bench, where it takes a GitHub issue and maybe it still can also run the test that were already pre-existing at that date in the code base. If you're really thinking of something that solves problems, the more you do in terms of testability, the easier it will be to iterate on that until I think if your testing is perfect and your reproduction script is perfect, and maybe you still have like a small filter that like whatever changes the agent makes aren't too long because you probably only look for like 3-line fix, I'm sure you can get a perfect solution by just trying long enough. There's, I think, a lot of very simple things you can do that involve no training. It's a lot more about like how do I pose the problems and how do I make sure that the agent has access to the best feedback from the environment possible.
And before this recording, Danny and I were chatting about how much this will transform how people contribute to open source projects. For example, at Databricks, we've hired a number of people just based off of their contributions to open source repos, for example, MLflow and Spark. And now it might be shifting towards who can build the best agent to solve these issues to just really accelerate productivity. So that's just been something that I've been thinking about, and curious to get both of your takes as to how you think an agentic approach to working on GitHub issues will transform software engineering.
Yeah, I think the like extremely straightforward thing, like you mentioned that, I think we've actually had some submissions from SWE-agent or other types of agentic frameworks to even our own like SWE-agent and related repositories. I think the most obvious thing about that is that, yeah, like as the cost of generating, say, a pull request or generating some new contribution inevitably goes down with the popularity and proliferation of agentic language model frameworks, there will be a major increase in the labor required to review all of these changes and have the oversight of ensuring that the new contributions to open source software is safe and reliable and makes sense and so on. So I think this is generally probably going to be a trend up across the board, not even just in open source repositories, but probably software engineers are going to spend a lot more time reviewing code and a lot more time in QA and a lot more time writing tests. And the historic framework of early software engineers writing a lot of code and senior software engineers reviewing a lot of that and ensuring that like integrations are merged, like that quality is like QA, the kind of QA component I think of software engineering is going to become a bigger part of everybody's job in a way.
Yeah, so I think it's right now most empowering for the maintainers themselves, maybe. I think if you're someone else who discovers a bug and you just run an agent and you just blindly submit the solution to the repository, I'm not sure how much you're really helping, because basically you should be able to you have to have a sanity check on your pull request. And as a maintainer, you have a lot of intuition about what feels right. Even not even talking about tests, but you probably just have a hunch of where problems come from and what kind of changes to make, and you will immediately have a reaction to seeing that pull request. So I would advise everyone like to try to at least understand what the agent was doing, where it's coming from, if that really makes sense. Don't flood poor maintainers with like hundreds of pull requests.
That makes sense. It's like same thing, just copying and pasting output from ChatGPT.
Actually, that recently just happened with a couple of repos. There was an external company, I won't mention them, but that decided to actually hit a few very popular open source repos. Oh, actually, both of them I'm involved with, so that's why I'm aware of them. And they just flooded them with issues. And literally, we're working on, as a community, we're working on, okay, do we need to actually literally add an additional checkbox? No, I'm not an AI robot. Because they're, just to your point, they're just sending lots of issues, right? On a more lighter note, this reminds me of the meme. My original job is software developer. My new job is AI code fixer or code reviewer. But while I say that in jest, one thing I'm curious about, actually related to this, is do you feel that while we're saying, hey, let's use ChatGPT or O4, O Mini, whatever else, do you feel that maybe some of the reasoning models will be more helpful? They'll be slower because the reasoning models, but perhaps then that will allow us to better understand, exactly to your point, what the LM is thinking and ultimately helping us understand what the agent was thinking?
Yeah, I think that's totally valid. We'll see. I think that probably these reasoning models will differ in the particular quality and interpretability of their reasoning traces, just the way that RL the kind of like training process that these reasoning models go to, I don't know if they necessarily, they're helpful for the state of the model, but I don't know how much that translates necessarily to the ability for humans to follow along. So I don't know. I've seen some kind of crazy reasoning traces out there as well in terms of these where it's not, I don't know how helpful it really is to thinking about like the actual solution at some point, but yeah, we'll see some, maybe hopefully some analysis, and as the models will get better, I'm sure those reasoning like steps will become more transparent as well. So
I think it's also important to keep in mind that also with humans solving problems, it's not just sheer intelligence that like decides on how good you are at solving problems. There's always like a very big kind of behavioral aspect to it. Like how do I iterate problems and how persistent am I and do I learn from things that go wrong? I bet that with a lot of jobs, it's not the most intelligent humans, but the most kind of long-term efficient humans that really are your best employees. And similar with language models, just good reasoning is not necessarily what an agentic approach needs. And maybe you can even get away with, I think there's very particular places where reasoning is very important.
Okay.
And it also depends on your approach, right? For example, when editing a file and the moment you're really saying, I have identified the cause of the problem, I'm going to now make an edit to fix this problem. Obviously, that's very reasoning heavy. Everything around it is not so reasoning heavy. It's okay, I'm going to rerun my reproduction script. I'm going to check if it's fixed and I'm going to look around to see if I find context. So maybe we'll see a little bit more of a trend to have agents that employ different language modes. And the other place where I think reasoning is very strong maybe is the sanity check, or maybe you even run 5 agents and you want to pick the best solution. And you could, for example, try to do that based on static analysis. And obviously that's very reasoning heavy. A little bit of a trade-off here, I think.
No, I actually can empathize. We fight this problem in Apache Spark all the time, where basically our logs become so long, and try to decipher actual information out of it becomes its own problem on its own, which is and so exactly. I think that if we end up over reasoning, then you're just going to be going through a massive amount of information trying to figure out what's actually useful here. Great, you went ahead and found the bug.
But I also like thinking about now, I think we talked a lot about the load of like how humans become reviewers of maybe AI pull requests in the future. Of course, you could also try to start summarizing these agent trajectories, and you could try really building, like currently coding environments and editors are emphasized humans editing code and like this kind of like editability. Maybe there's going to be a trend to like very specific tools that are only about reviewing and poking around the code base, trying to make sense of it. There might be very specialized tools to ease that load on human developers.
No, that's really cool. And then, okay, so we're definitely running a little long, but this is super exciting. So I want to at least make sure I ask the question, like, yeah, how do folks get started with SWE-agent and SWE-bench, right? Like, how do they get started? Because it's certainly exciting. It's certainly really cool. So how do we get people on this podcast to get started on this?
yeah, so SWE-bench is mostly a benchmark for evaluating these agentic systems, and I think it's most helpful. So when you have something that you want to test out, and you can use like SWE-bench's GitHub repository to say test your system, and that's definitely something that's helpful. And you can compare that to maybe what's on offer from other companies or other open source repositories. For SWE-agent, SWE-agent is more of an agent scaffold. I think I'll let Kilian explain since he's been working a lot on the recent release.
Yeah, so to get started, you can check out our GitHub repository or go to our website. It's SWE-agent, so SWE-agent.com. You can look at the documentation of how to get started. You can also read the code base. I think our goal with SWE-agent is really to make it simple and hackable in a lot of different ways. I think there's a big span, and it's probably this distinction will get even larger in the future between like how much is it a tool versus how much is it something to test new ideas. I think we're somewhere in the middle. You can certainly use it as a tool, but you can also, it's very easy to hack or to configure. Adding tools is now easier than ever before. Basically, you can just write a Python or a shell script, you put it in a certain folder, you add one YAML file, and boom, it's a tool that you provide to the agent. You have to just tell it to use it. I think that's the easiest way to get started. Only let us know if you have questions. I think the emphasis is a little bit on if you have new ideas, you want to play with this technology and maybe you're going to modify some of the code. I think that's just a really nice way of doing that. But if, for example, you just want to write your own agent completely from scratch and you have some completely different ideas, we also, in our efforts to make SWE-agent simpler, we took a large chunk of very annoying code, namely how to boot up these environments, like basically use Docker environments and execute code in there. And all of this environment management and how do we communicate with these Docker container stuff is now its own project called SWE-regs, like T-Regs. Sweet fun. Anyway, it's SWE-regs.com. It's a very small code base, so it's very easy to hack. And essentially, you can just, in 5 lines, you can just boot up a Docker environment and then start communicating with it. So it runs a small web server and you talk to that web server. And for example, you can tell that web server to execute your command and get the output. So with that, I think it's also very easy to write your own agent if you want that. But of course, SWE-agent is very nice, very configurable, very hackable. Please try it out.
Awesome. I love that call to action to help close out our episode. Test out SWE-bench, play around with SWE-agent, perhaps become a contributor. Do not flood it with issues generated
Yes,
by
please do.
agents. So yeah, Carlos, Kilian, thank you so much for both your contributions to SWE-bench and SWE-agent, and thank you for joining us today on Data Brew.